Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 3 of the series of videos on probability Venn diagrams, and in this video I'm going to be going through an example where we've got some conditional probability going on to enable us to find probabilities within a Venn diagram. So here we go. Events E and F are such that the probability of E is 0.8, the probability of E given F is 0.6, and the probability of F given E is 0.24. So, first thing I'm going to do is just label my two sections of a Venn diagram as E and F, and then I'm going to look at what I've got here. Now, I've been given the probability of E, the probability of E given F, and the probability of F given E. Now, this is going to be the more useful one, because the E bit is going to be the denominator of my fraction, and I know the probability of E. So, first thing I'm going to do is to write out the conditional probability formula for F given E. Now, in a previous video I said that whatever the second bit is, the given that bit, that's going to be the probability of that on the denominator, so probability of E on the denominator of the fraction, and on the numerator it's going to be the intersection. So there's my formula. Now it's just a case of working out which bits of that I know. Well, I know the probability of F given E is 0.24. and I know that the probability of E is 0.8. So I've got the probability of F given E on the numerator of that fraction. So that's going to enable me to find out the probability of the intersection by doing 0.8 multiplied by 0.24, which is 0.192. And that is the probability of F intersect E. So the intersection, a bit in the middle, so I can go right ahead and do a bit of slanty writing there to get 0.192 in the centre. Now, I knew that the probability of E was 0.8, so now I know the intersection bit. I can subtract that from 0.8 and get 0.608 as my probability of just E, those two values adding up to the 0.8 in total. So I need this section here and the outside section. So I'll go back to what I've been given. Well, I've also been given the probability of E given F. Now, I'm going to write the formula out again that I'm using. The probability of E given F, remember, the given that thing, the second thing goes on the denominator. So probability of F on the denominator. And the probability of the intersection goes on the numerator. Now, I know that the probability of E given F is 0.6, and I've just worked out that the intersection is 0.192, and I've got probability of F on my denominator. So if I do 0.192 divided by 0.6, I will find out the probability of just F, which is 0.32. Just got to be a bit careful here though. It's not 0.32 here because that 0.32 includes the 0.192 in the centre. So subtracting, I get that to be 0.128. And what that should mean on my outside is if I add up that with the 0.8 for E and subtract that from 1, I should get 0.072 as my outside section, so not E and not F. Okay, so I've used the conditional probability formulae to find out all the values in my Venn diagram, and now it should be fairly straightforward to just find the information I'm being asked for on the Venn diagram here. So, probability of E intersect F, well, we did that fairly early on, we got 0.192. We worked out the probability of F to be 0.32, that was the second bit we did. And now we're looking at the union. So the union of E and F is anything in E or in F, so everything except the bit on the outside. So I make that 0.928. Probability of not E intersect F, so we're not in E but we are in F, that's the 0.128. Not E intersect not F, so we're not in E and we're not in F, that's the 0.072. And finally, the union that everyone hates, the not E union not F. So you remember in previous videos we've talked about how that's everything except what's in the middle. So if I do 1 minus 0.192, that one comes out as 0.808. Okay, I've got one more thing to do here, which is state giving a reason whether or not events E and F are independent. So my test for independence is that if E and F are independent, then the probability of E multiplied by the probability of F will give the probability of E and F the intersection. Now my probability of E was 0.8, and the probability of F I calculated was 0.32. And if I multiply those two things together, 0.8 times by 0.32, I get 0.256, which suggests that they are not independent. So E and F are not independent, because if they were, rather than equaling 0.256, that would have equaled 0.192. Okay, there we go. Join me in the next video where we'll do another one. See you then.